Happy Friday. It's Beverly Adams, your A&R program assistant for the UGA Extension Office here in Forsyth County with my pest of the week, scale. Scale insects are a common pest of landscape trees and shrubs that are often overlooked when you're out scouting for pests on your plants. They can be responsible for chlorosis, branch dieback, and ultimately plant death. They are categorized as either soft scales or armored scales. Soft scales produce a soft, cottony, powdery, or waxy substance that cannot be separated from the scale body. Armored scales have a hard, shield-like cover that is not attached to the body of the insect. Soft scales produce honeydew because they feed on a high-volume liquid diet drawn directly from the vascular tissue that transports dissolved sugar and nutrients within the plant. This liquid can attract ants and supports the growth of the unsightly black sooty mold fungus. Most soft scales have one generation per year, with a few exceptions. Many retain their legs throughout their life and can move around on the plant. Soft scales secrete a wax covering, protecting them from natural enemies, pesticides, and desiccation. Armored scales are generally flat in appearance, nondescript, and well camouflaged, and they do not produce the honeydew. Instead, they feed by bursting plant cells and eating the contents. They do not directly access the vascular bundles of the plant, and their waste is produced as their protective hard cover. After emerging from the egg as a mobile crawler with legs, armored scales find a suitable feeding spot and they settle down, lose their legs, live beneath their protective scale covering and previously molted skins. Except for adults, armored scales do not move after the first molt. Most of the armored scales have multiple generations per year. So the biology and life cycle. Scale insects spend most of their lives immobile under their protective coverings. When the eggs hatch, the mobile crawlers walk or are blown by the wind to new locations where they settle and begin to feed and produce their own protective coating. The mobile crawlers do not produce protective covering on the body. When the larvae molt, they add a layer of protective covering on the previous one. For some armored scales, the added layer increases in diameter as the larval size increases within the covering. Most scales undergo 3 to 4 larval stages. Many soft scales spend the winter on twigs and bark before crawlers move to new foliage in the spring. Some scales are strictly bark dwellers and can be the most difficult to control. Scouting. You'll want to check the bark of plants and flip over bumps or lumps that could be scales. If there is a soft body underneath the scale cover, it is an armored scale. If the whole bump or scale body comes up and can be squished, then it's likely culprit. Then it is the likely culprit. If ants or wasps are attracted to a plant's foliage, look for honeydew producing scales or aphids or mealybugs. Paper wasps can be attracted to honeydew, but they also hunt for caterpillars to feed their young. The crawler stage is particularly vulnerable to control efforts and can be detected only through close inspection. Consider placing double-sided sticky tape on branches with winter scale populations to detect crawlers hatching in the spring. Cultural control. Scale insects are primarily drawn to stressed host plants. Stress can be caused by several conditions: too little or too much water, nutrient deficiencies or toxicities, or temperature extremes. The presence of impervious surfaces around the host tree or shrubs can increase the ambient temperature, increasing the number of eggs per female scale of female scales, which leads to rapid population growth. Early detection is the key for successful management, so scouting should start a week before crawler emergence. Because damage and infestation of scales can be specific to certain tree or plant species or their cultivars, the cultivar identification and selection of host trees or plants are important. If infestation is high on certain branches or twigs, immediately prune those parts, and that's probably the best way to reduce infestation. Pruning often allows improved light, which can improve scale control. The pruned branches or twigs should be immediately removed from the infested area and destroyed to prevent reinfestation from the surviving scales. Do not compost infested branches. The pruned branches can be disposed in tightly secured trash bags and left under the sun, and the heat generated inside the bag will kill the scales. Biological controls. Scales are primarily managed by natural biological control measures. Natural enemies play a critical role in keeping the scale population to low levels. The natural enemy complex includes several species of ladybugs, predaceous mites, and parasitic wasps. Both larvae and adult lady beetles feed on scales. Young larvae of certain lady beetle species are smaller than others, and they can go underneath the scale shield and feed on the developing scale. Several species of parasitic wasps naturally occur in the landscape and use scales as hosts. The female wasps lay their eggs on or inside the scales, and the wasp larvae feed on the scale. The parasitized scales usually turn black and can be identified by an exit hole on the shield through which the adult wasps have emerged. For chemical control, regardless of soft or armored scales, applying horticulture oil during the winter can destroy the overwintering scales. Similarly, a delayed winter spray of oil before bud breaks is effective in killing certain scale species. In spring and summer, if scales are feeding on the woody tissue, bark, and twig, topical applications of oil or insect growth regulators like pyriproxine or buprofizin at least twice during each crawler emergence period can improve control. Other insecticides such as insecticidal soap and neonicotinoids can also be used, especially on soft scales, but care should be taken to avoid affecting natural enemies and other non-target organisms like bees. Horticulture oil and insecticidal growth regulators are considered reduced risk insecticides as they are relatively safe to humans, have reduced non-target toxic effects, and are compatible with other integrated pest management approaches, including biological and cultural controls. Please read the precautionary statements on the insecticidal label to reduce exposure to non-target organisms like pollinators. Multiple applications of insecticides may be required during the emergence period if insecticides are applied as a foliar spray, especially for armored scales. Again, please read the label for rates and specific restrictions. Additionally, the location of a scale infestation within a tree or a shrub is an important factor if a systemic insecticide is used. Typically, systemic insecticides move upward from the root system to the foliage and end up in actively growing leaves. Most soft scales tend to infest the foliage, and any systemic insecticides can be effective on those scales. However, armored scales typically infest the twigs, branches, or bark of the host tree or shrub. Armored scales are usually exposed to lower doses of systemic insecticides than scales that infest the foliage, because systemic insecticides usually move through the vascular bundles and do not stay there. Also, most armored scales do not directly feed on the vascular bundles, but on the leaf's green photosynthesizing cells. By feeding this way, they're exposed to low doses of applied insecticide that can cause mortality. Among the neonicotinoid insecticides, dinotefuran is effective in reducing armored scales, partly because it's most water-soluble and mobile within the host plant. Repeated applications are warranted if dinotefuran is used alone, as the residue of this insecticide doesn't last long and will not provide adequate longer-term control. Finally, the size of the host plant is an important factor to consider when using insecticides. Again, dinotefuran has shown efficiency against scales on canopies of large trees within a short time, 2 to 3 weeks after the soil or trunk injection, mostly because it has a high water solubility and can move rapidly within the tree. In contrast, neonicotinoids like imidacloprid will require more time, up to 2 months or more, to show signs of efficiency, as they are relatively less water soluble and mobile within the tree.